So your agent now sounds great and survives outages, but how do you know if it's actually performing well? Well, this lesson covers three connected topics: metrics collection to understand your agent's behavior, deployment to LiveKit Cloud for production observability, and latency optimization techniques, including preemptive generation. So by the end, you'll have real numbers to optimize against and the tools to track them in production. Now, before we jump into the code, let's talk about what you're actually measuring. So time to first audio, TTFA, this is the delay from when the user stops speaking to when they hear the first word of the response. This is the number users feel most directly. And then time to first token tracks when the LLM starts generating, which helps isolate whether delays are coming from transcription, the model, or speech synthesis. You'll also track token usage for cost estimations, interruption rate to see how often users cut off the agent, and fallback activations if your primary providers fail over. We're going to see these metrics show up in console logs during development and in LiveKit Cloud's dashboard in production. The key takeaway here is going to be TTFA, time to first audio. We want that to be less than 1 second for most responses. Let's start by collecting usage metrics. The first thing we're going to do is add some imports here. So we're going to import agent state changed event, metrics collected event, metrics. All that comes from LiveKit agents. And then we're just going to define our logger here. And then we'll go down to our entry point function. So just before the session start, we've added this code block here. So let's break this down to see what this does. The usage collector aggregates data across all conversation turns. It tracks token counts for the LLM, audio durations for STT and TTS, and cost estimates when available. The metrics collected event fires after each component finishes processing. You're capturing EOU metrics specifically, which stands for end of utterance. This is the moment when the turn detector decides that the user has finished speaking. And then when the worker shuts down, log usage prints a summary so that you can see per session resource consumption. So the agent cycles through several states during a conversation: listening, thinking, and speaking. The agent state changed event, it fires each time the agent transitions between these states. When the agent enters the speaking state, you want to know how long the human waited. So back in our code, below that code block that we just added, let's add another, and then be sure to import time up above here. We're using that in this new code block. So this new block here, this gives you a real number to optimize against. You can watch the console output and see exactly how long users wait for each response. So we'll see this being printed in the console after each response. Now, preemptive generation lets the LLM start forming a response before the user finishes speaking. The agent waits for a clear end of turn before actually speaking, but the thinking has already begun. We can enable this in a single line. If we go back up to our agent session, we're going to add another line here. And it's just preemptive generation and equals true. That's it. So this can save hundreds of milliseconds off of perceived latency, especially for longer user turns. The LLM gets a head start on generating the response. But that's not to say that preemptive generation is 100% good all of the time. Preemptive generation trades accuracy for speed. There are a few scenarios where this trade-off might not work in your favor. For instance, mid-sentence direction changes. If a user says, "Book me a flight to New York," no, actually make that Chicago, the LLM might have already committed to New York. Second, complex multi-part instructions. Long requests with multiple steps can get partially answered before the full context is available. Third, high accuracy domains, medical, legal, or financial applications where getting it right matters more than getting it fast. But for many conversational use cases, preemptive generation works well. But if you notice that the agent is jumping to conclusions or misinterpreting intent, consider disabling it or tuning your turn detection thresholds. So let's test out these metrics and see them in action. So go ahead and open up your terminal and we'll run UV run agent py console. Hello, agent. How are you?
Hey there. I'm great. Thanks for asking. Ready to tackle your tech troubles.
Yeah.
What can I?
Let's see. What troubles am I having? Yeah, my iPods have been like making crackling noises. What's up with that?
Crackling on iPods usually means dirty headphone jacks or a software glitch.
Ugh,
Try cleaning.
that sounds terrible. Okay, let's take a look at these metrics. So let's go up to, all right, so here we go. We've got some STT metrics here. We get the model name, the provider, and then the audio duration. We've got some received user transcript here. Let's move on. STT metrics again, received user transcript. There's some EOU metrics here. Again, multilingual, provider, end of utterance delay, 0.65. Time to first audio, 0.889 seconds. So a lot of great information here that we can use to tune our agent. Now, when we press Control C to stop our agent, we then get this summary here. This nice little usage summary. This shows us the total tokens used, the total audio duration processed, and estimated costs if they're available. So we can see completion tokens there, character counts, audio duration, STT audio duration versus TTS audio duration, LLM prompt tokens, 154. So you now have visibility into your agent's performance. The metrics show where time is spent, how many tokens are consumed, and how much audio is processed. So use this data to identify bottlenecks and optimize your pipeline. Remember this table from lesson 1 with a best case total around 400 milliseconds, but a typical latency around 1 or 2 seconds. Any TTFA under 1 second is solid. So you're seeing about 800 milliseconds here, which puts this response in a good territory. Now, local testing and metrics is fine at first, but you'll want something much more robust in production. And so you can use external tracing tools like Langfuse if you want, but LiveKit Cloud includes built-in observability for agent sessions. So you can view transcripts, traces, logs, and even audio recordings directly in the LiveKit Cloud dashboard without any additional steps. LiveKit's observability is also OpenTelemetry compatible. So you can also export traces to any OpenTelemetry compatible backend if you prefer. Our dashboard here shows 3 synchronized views. The transcripts with audio playback let you scrub through the conversation and you can hear exactly what happened. The Traces tab breaks down each turn into spans for STT, LLM, TTS, and tool calls with detailed timestamps and durations. And then Logs shows real-time messages from your agent server in chronological order. All of this data is synchronized to a single timeline, which makes it so easy and so simple to see exactly what is happening under the hood. Now, observability needs to be enabled in order to use it, and we can do this at the project level. So go to your LiveKit dashboard, and then under Settings, we'll go to Project. And then we can scroll down to Data and Privacy, and then Agent Observability, and just make sure that that is enabled. And then go ahead and save your changes. Now, once it's enabled, all agent sessions will automatically record data. The Agents SDK version for Python needs to be at least 1.3.0 or higher, or 1.0.18 or higher for Node.js. And recording happens automatically. You don't need to change your agent code at all. Audio is collected locally and then uploaded after the session ends, along with transcripts and traces. Now, to view observability data in the dashboard, you will need to deploy your agent to LiveKit Cloud. Running locally is, again, fine for development, but we're at a place now where we want to start observing the performance of our agent. The decisions that we make from now on are going to have impacts on our agent, and we want to know if a tool that we're adding or some feature that we're adding is introducing some poor performance. Now, deploying to LiveKit Cloud gives you automatic scaling and load balancing, so your agent can handle multiple sessions without manual configuration. And the built-in observability integration means that transcripts, traces, and audio recordings upload automatically. Your agent runs on LiveKit's global network infrastructure, reducing latency for users worldwide, and you don't need to manage servers or containers yourself. So it's a win-win. First, you'll need to make sure that you have the LiveKit CLI installed. If you don't have it installed yet, you can install it with Homebrew on macOS, or you can download the binary from the LiveKit documentation. There's a link in the video description. So once you have that installed, we'll do LiveKit Cloud auth. So that's going to pop us over to LiveKit Cloud and ask us to confirm. And we'll go ahead and select a project that we want to give it access to, and we're going to hit allow access. Cool, now we can go back to our code editor. So now deploying our agent is as simple as a single command. Okay, agent, create. You can specify which project if you have multiple, but I'll just go ahead and select this project, yes. Select the secrets. I already have my environment variables set up. If you didn't already have them, then it would create them for you. So we'll go ahead and select the existing environment variables. We can select a region, US East or EU Central. So I'll do US East. So this command, it does several things. It registers your agent with LiveKit Cloud and assigns a unique ID. The ID and the project configuration are written to a new LiveKit TOML file. And if you don't already have a Docker file, the CLI is going to create that for you as well. And then it uploads your code to LiveKit Cloud's build service, builds a container image, and then deploys it to your project. So you can see the build logs here streaming to our terminal as the container image is creating. And this usually just takes a minute or two depending on your dependencies. Now, once the deployment is complete, your agent is going to be live on LiveKit Cloud and ready to handle sessions. The agent automatically scales up and down based on demand, and all of the observability data will upload to the dashboard after each session. All right, so now it's asking me if I want to view logs. No, I don't care about logs, and we're done. So now let's test the deployed agent to generate some session data. So notice here, we didn't have anything under agents. Let me refresh the page. And now we can see our new agent. It's here. So we can get an overview of our agents here. If we click on our agent, we can then see some more detailed information about our agent. But in order to test it, let's go over to Sandbox, and we're going to create a new sandbox. So we'll create a new web voice agent sandbox, and let's go ahead and create this sandbox here. You can give it a name or just let it randomly generate a name. Let's go ahead and create it. And then we don't need these instructions. Let's go ahead and launch this. It's going to use our agent. So let's go ahead and click Start Call, and we'll need to enable the microphone. Hello.
Hey there. What tech trouble can I zap for you today?
More tech trouble. I'm actually not having much tech trouble. So thank you. We'll go ahead and end the call. And now we should have some observability data on that really brief call there. But you can see it was still the same agent that we created, the same voice, asking about tech trouble. Let's go ahead and go back over to our dashboard. And this time, let's go ahead and click on sessions. And we can see our latest session here. We can click on it. We have this Agent Insights tab. And this is where we can see our observability data. And here is that timeline. So we can go ahead and click play here. Hello.
Hey there. What tech trouble are we tackling today?
It looks like I ended it before my last response actually made its way up. So I probably should have talked a little bit longer, but you can see it recorded my audio, the agent's audio. So the transcript view shows the conversation timeline with audio playback. You can scrub to any point and hear exactly what the user and agent said. And inline alerts highlight key events like tool calls. And this view is great for spotting interruptions and understanding the conversation flow. So we can see here that the agent latency was 1.5 seconds. If we click on it, we can see some more stats. Now, the trace view is where you'll spend most of your optimization time. Each agent response breaks down into spans for STT, LLM, and TTS. You can click on any of these and see extra details, timestamps, and durations. And this is where you can find and identify bottlenecks. If your LLM span is consistently over 500 milliseconds, you might consider a faster model or enabling preemptive generation if you haven't already. If TTS is the bottleneck, try a different voice provider. So here again, we can click on the agent turn. We can see the LLM node, and we can get all this extra information. Same with the TTS node. And when the agent speaks, we get all of this extra details that can help us. So we can see exactly where time is spent in each turn. So in this example, we can see the LLM node is taking 793 milliseconds. The TTS node is taking almost 2 seconds. So that's right there. That's where we can start considering optimization. So going over to the logs view, this is where it will show information, warnings, errors, and debug messages from your agent code, the media server, and client connections. So if something fails or you see unexpected behavior in the transcript, click here for the technical details. Again, we can click on each of these to show the extra information. Now, the really cool thing about observability here is that everything is all aligned to the same audio track. And so as we're scrubbing through the audio, we are in the same timeline, looking at the same things in all three of these different views. So they're all in sync. So if you have observability enabled at the project level, but you want to disable it for a specific session or for a specific agent, you can do that. So we'll just go down here to session start, and then we can add an option here. We can add record equals false. Pretty simple. And now this agent will no longer collect observability data. So this disables the upload of audio, transcripts, traces, and logs for the entire session, even if the project level setting is enabled. So use this when you need to handle sensitive data or you want to reduce storage costs for specific sessions. Now, all observability data is stored in the US and is retained for 30 days. And data older than 30 days is automatically deleted. And you can download the audio, transcripts, and logs directly from the session if you need a copy. Now, for projects on the free build plan, some anonymized session data may be retained longer for model improvement purposes. Paid plans, including Ship, Scale, and Enterprise, have full data deletion after that 30-day window. Now, low latency voice requires parallel work across the stack. So here's some best practices. First, stream everything. STT, LLM, TTS should operate incrementally, not in big batches. Second, parallelize. Start TTS as soon as the LLM emits the first words. Don't wait for the full sentence. Third, avoid blocking I/O. Keep tool calls and storage async. Bound your timeouts and retries. And fourth, keep prompts tight. Fewer tokens means faster first audio and lower cost. Now, the metrics you collect at the application level only tell you part of the story. Network conditions also affect perceived latency. WebRTC handles this with Opus audio compression, jitter buffering, and adaptive bitrate. So if you see unexpectedly high time to first audio that doesn't correlate with your pipeline metrics, network conditions may be the culprit. Use agent observability to validate and fine-tune agent performance. The trace view shows exactly where time is spent in each turn. So this makes it easier to identify bottlenecks. So to recap, these are the metrics worth tracking as you continue building. You've seen them in the console output during development and in the trace view in production. And so aim for a time to first audio under 1 second in most cases, and use the trace breakdown to identify which component to optimize when you're over budget. So you've learned which metrics matter for voice agents and how to collect them locally. You've improved latency with preemptive generation. You've deployed your agent to LiveKit Cloud, and you've seen how agent observability gives you transcripts, traces, and log views to debug and optimize each session. With metrics and observability in place, you can make data-driven decisions as you add tools and workflows in the next lesson.